Hey, what's up guys? Jeremy here. Using robot to mill or machine parts is getting more and more common in the industry. And there's a very good reason for that. You can create much bigger 5-axis working envelope with a robot for a fraction of the price compared to a traditional CNC. Today, we are happy to announce that we have a new integration with the machining software BobCAD CAM. With this integration, you'll be able to take what you created in your machining environment and bring it to RoboDK in a matter of seconds. Let's get started. As some of you may know, RoboDK can convert NC code generated for a CNC machine into something understandable for the robot controller. We've been doing that for a long time, but it's sometimes a bit tricky. You need to know exactly what post-processor you want to use and what parameters should be activated. With the plugin for BobCAD CAM, you don't need to bother with that at all. Everything is preset for you. You just have to create your process within the CAM environment, and then with one button, it will be imported inside RoboDK for optimization and to generate the robot code. Super easy. So let's see how we can do that. First of all, let's open BobCAD CAM. So here we have a very simple part. So it's a pipe mold. And the process would be to deburr the edges on the top plate here with a robot. So inside BobCAD, we use one of their newest feature, the 5-axis deburring process, which worked extremely well for this setup. So if we were to select the start simulation to see what it looks like, inside BobCAD environment, you should use a 5-axis generic machine. So this one won't have any physical limitation. It won't give you any warning if you're exceeding the joint limits, and it won't give you any warning for collision in the simulation environment. This will be taken care of within RoboDK. So if I use my progress bar here, I can see that the process is simply to move around that little corner here. So I can close that here. When you install RoboDK's plugin for BobCAD, you will have a new tab here and 5 buttons. So I won't explain you how to install the plugin in this video. I will do that in the third video of this series. In this one, I will simply show you how to quickly use the bridge or the integration between the two softwares. In the second video, I will show you how to do a more advanced project using a 7th axis or a turntable to increase the reach and type of parts you can handle with the robot. And in the third video, I'll show you how to install the plugin and some little settings that you can play with depending on your needs. So here, what you can do is obviously robot setup, load part, update operations, generate program, and then settings. So before pressing any of those, I would like to go to our RoboDK environment. So here we have your 3D environment, Station 3 toolbar. For people that are more familiar with our software, you know that you can easily create your station here. So you simply open our online library, you pick the right robot, you press open, it will open inside RoboDK. Then you can bring any other objects you need. So a table, a stand for the robot, your tool. As long as it's either step, IGES, STL, you can import it in the virtual environment and then convert it into something usable here. So you'll be able to make sure that you don't have any collisions, that you have enough reach, and all of that good stuff. But if you don't know RoboDK and just want to test the power of this integration or the features that you have, you can select here Robot Setup. If you press this, it will simply open a default station inside RoboDK here, a very basic station with a robot, a spindle, and 2 frames. I would invite you to delete frame 1 and select drag and drop machining reference into RoboDK robot base, or in fact the KUKA robot base. So if you press Alt here, you can move the robot around either with a plane, an axis, or by rotating around one of the tool axis. You can do the same with the frames. So the frames will be your part origin or your machining origin. If you double click the robot here, you can do the same and move the robot one joint at a time. So that's interesting. I will hide the flange here. I don't need to see it. So robot flange, right click and move the robot back to its own position. Before we go back to BobCAD and start importing our part and our path, I would like to do one last modification to our robotic environment here. As you can see, we have a TCP or tool center point, but it's positioned exactly where the holder of our tool is, or the holder of our spindle. So we won't be cutting with our holder, obviously. So we need to create a new TCP representing the length of our cutting tool. So we can do so by right-clicking the robot here, either in the station tree or the 3D model in the environment, and select Add Tool. It will by default create a tool 200 millimeters in front of the flange. If we double-click on it, we'll have our tool panel. What we'll do now is we will set that up with respect to our spindle or our holder. We will reset all of those to 0 by clicking the 3 little bars here and selecting Reset. Then now both the spindle and the tools are at the same spot. So now I can enter the length of my cutting tool right here. So in this case, 200, let's say. So that's perfect. And now I can simply hide this TCP, right-click, hide this TCP here. And then I want to activate tool 2 as my active tool, just like that. Awesome. So now we have a starting point for our project. Let's go back to BobCAD. And one thing we can do is select Load Part. If we do so, BobCAD will simply save the part as an STL in the background and then load it into RoboDK just like that. Awesome. So if I press plus here, as this part is part of our robot base, or in fact our machining reference here, we have the part. If I move the machining reference around, the part will follow along. So that's cool. Right click, I can align it to square it with our robot base. So I can go press minus a few times, and I can go back to BobCAD. And now the real thing starts. So I can press here, update operation. This will take this first operation and bring it into our robotic environment. So here we have now in our station tree, our milling job 1T1. It created a robot machining project called milling 1T1. And as you can see, if we move closer, it created a bunch of points to reach our different position. So that's the first thing. Then what you need to do is move the robot around to a configuration and orientation you would like to use. So I would say, okay, I would like the robot to be positioned something like that when it does the project. So I'll click here, Teach. It will record that rotation orientation. I'll click Show Preferred Toolpath. So now as you can, this will create ghost tools that represent how the robot will behave along the path. So as you can see here, the flange will always be pointing upward. So that's cool. If I was to click here, Show Estimated Toolpath, it will have a bunch of green tools appearing, telling us that all of these targets are within range of the robot. You can play with the approach and retract motion. So in this case, I will remove them because the machining project already creates lead in and lead out. And then we can select here, Set Current, to take these joint values and say, okay, I would like to use that as my starting point. So because there's many different configurations to reach the same point for those who are a bit more familiar with robotics. I'll click Update, and then I will click Simulate. I'll take my process because here this won't run very fast. I'll take my progress bar and I will move the slider around. So just to see what my path looks like. So that's cool. That's awesome. I can close this here. I can now have a milling job program. So white program, right click, show instructions. So we'll see all the instructions that were generated or translated from the NC file. So we have a rounding to have smooth motion. We have our set tool, select the right tool, select RPM. We then have all of our motions, all of our speed changes. So every information that is part of our CAM program will be translated and transferred here. So that's cool. So I can now right click and select generate robot program. So this will create a program here called Milling Job 1T1 SRC with all the motions, the tool, the velocity changes, and so on and so forth. So that's pretty cool. This is our program. We can load that onto the controller. It's in this case, it's an SRC file or source file for the KUKA controller, but it could have been a mod file for the ABB controller, an LS file for the FANUC controller, and so on. So that's the first thing. Next thing we need to do is bring in the other section here. So we'll just go back to BobCAD. And the reason why I was able to import just one corner, and even if you see all the other, let's say, green lines here, is because I kind of muted the post-processing of the other one. So if you can see here, I have like X's, and if I click here, this will bring in red X's too. And if I right click, I can also select post yes, no, which will have the same effect. So what I did pretty much is I just muted the last three process and just loaded the first one. So that's a good thing to kind of get started one thing at a time. So then I can go back to RoboDK's tab and select update operations, go back to RoboDK, and now I have 3 new robot machining projects that were created. So I could go and open them one after the other and reset up everything the same way as I did for the first one, or I can right click the first one, more option, copy settings, select all the others here, right click, and then paste settings. I can right click and then update programs. So just like that, cool. So now if I run this one here, this will be the last 3 sections. If I want, I can add the first one we created to our main program. The main program was kind of automatically created when we imported a bunch of programs together. So what we can do here, we can update this program, meeting job. I can right click, add instruction, and this is a program call. So I want to call this program here. And then I will select my meeting job here, click OK, right click, hold, release. I want to put that before. Excellent. By the way, I did not mention it, but here within RoboDK, you have optimization parameters. So those will help you automatically avoid singularities, joint limits, reach limits, and all the other, let's say, mechanical limitations you could face with a robot. Now, if I double click the main multi-axis deburring, first section, second section, third test section, and fourth section, perfect, right click, and then we'll go to generate robot program. Great, so now I created a main feature multi-axis SRC. Here you only have the program calls for the 4 programs we have. Those were saved inside the same folder as this one was saved. You could also activate an option called inline subprogram, where all the motions will only be post-processed in like one big bulk inside the main SRC. So those are possible. So that's pretty much everything for this video. I hope it was helpful. In the next one, like I said, I will show you how to create a more advanced part. It will be a statue that we will mill, and we will place it on a turntable to have more reach and to be able to really like turn around the statue. So that's it. So I hope to see you there. And in any case, have a great day, guys.